Hi everybody! What we're going to cover in this section is the foundations of language. And this is a rather long section, so I'm going to try to break it up into 2 or 3 videos. But first, let me show you something. So, if you're having problems with cats annoying you during your videos, I can't guarantee this is going to work. But what you do is you set a trap for them so that they sit in a box and not on you. So, we'll see if that works. Until then, here we go. So, we're going to start with what are the origins of language. So, how did humans come to have language? So, this is a little bit of anthropology for you. But there are several different theories. And so, one of the big theories is sort of the onomatopoeia one, is that language started as a sound base. So, anything that makes a noise we were mimicking. But that only works so well because it doesn't really explain the wide variety of words that we use that don't really have anything to do with sounds that people make. So like bark works, but that doesn't really explain dog. And there is, in theory, no relationship between the symbols that we use and their meaning, and so this theory doesn't really hold water. It may have started that way, but it quickly needed to evolve because there just weren't literally enough sounds. And what sound do you do for a lot of your abstract words? And so that just didn't work. Okay. Some other theories are evolutionary, so that as brain size increased, our vocal cords developed. And this is fairly well supported. And so we sort of got the brain space to be able to have language, and so those vocal cords, through a mutation in genetics, were sort of at the right time in the right place, and so that's their development was aided by this increase in brain size. There are some arguments that there hasn't been enough time evolutionarily for language to evolve in that sort of way. And Chomsky sort of argued that grammar doesn't really evolve, it sort of is or isn't. And the people who argue for evolutionary things say that grammar isn't really something that saves your life. And so it doesn't have a natural selection pressure. However, the argument is that language does have evolutionary pressure. It is a good thing to have because it allows you to forage for food, social bonds, lots of different things other than just an understanding of grammar. So Chomsky's theory maybe not so well supported, but the idea of language being an evolutionary mutation is a little supported. And so that's what this theory is. Many of those original arguments have been supported. So it kind of went through a phase where we didn't think that that was what caused it, and now we kind of do. There is a natural advantage for communication because it helps you avoid predators and find food. However, maybe there's not a natural advantage for grammar, except in the sense that grammar allows us to all be on the same communication system, which does have its advantages. So if you've ever talked to someone who doesn't speak English, there is a pressure for you at least to be speaking in the same type of system so that you can understand word order or at least somewhat of the meaning of what they're saying. So evolutionarily, we think that there was some sort of proto-language. It's like some language somewhere between sounds and hand pointing as a language to current language. And we think it was about 1.6 million years ago with Homo Erectus. Obviously, this is all theory because we can't really travel back in time and figure it out. But there are ways in the brain that we can look at these sorts of things and tell what they would have been capable of given biology systems at that time versus later in the development of the Homo sapiens line. And so that sort of Chomsky's all or nothing idea isn't actually supported even well today, because if you look at research on language development now, and I'm talking about development of a language, not language developing in a person, what you'll see are these Pidgins. So Pidgins are where two languages sort of come together and are very rudimentary. So if you put two people together who don't speak the same language, they start by just looking at the words that they both know and sort of communicating that way. Creoles are when languages blend, and Creole with a capital C is an English-French blend. But they sort of go through this progressive development from Pidgin to Creole to full language. And so there is support for this idea that languages themselves develop. They develop in young children. We're going to talk about some research on primates and this idea of critical periods. So Chomsky isn't totally right. He's a little bit right, but not totally. So if we talk about sort of the archeology of evolution, there have been changes in Broca's area. Broca's area is here in the front temporal lobe. If you are right-handed, it is predominantly found on the left side of the brain. If you are left-handed, have fun, you're with me. It could be on both sides of the brain or the right side of the brain. Lefties are a little weird. There have been some changes in the tongue and larynx, which allow for fine motor control. So those have evolved to allow us to have more muscles and a more fine-tuned movement. Because as you saw in the last section, pronunciation and phonemes are really complex. And so the ability to enunciate in all those different ways really speeds the development of language, because now I have the ability to say more sounds, and more sounds means more words and more capability to create these complex ideas. We have seen increases in brain size, which just gives us more room to work with, so to speak, and changes in intelligence levels. So what we're seeing is across the record of human existence, we see these changes that allow us to develop language. So these might be small mutations over time, but they supported the development of language, so natural selection had a better chance on those things. We can look at biology in humans now. So there's some recent evidence for FOXP2. It is not a full gene. It's part of a gene. And it doesn't control grammar. Like if you don't have FOXP2, you don't have grammar. It runs in shades. And so if you have some damage to that gene, you have language acquisition problems, meaning it's hard for you to acquire language. Grammar is difficult but not impossible. So it is not the grammar gene. That's what people will call it if you Google it, but it is some really hard evidence for grammar being innate, in the sense that it does seem to have some biological underpinnings. Okay? And they think that the mutation in that area was about 100,000 years ago, and it helped to develop Broca's. So Broca's, remember here in the front, Broca's is an area that tends to do what do I want to say in response. So the way I remember Broca's is it's like, what do I say to that? Versus Wernicke's, which is in the back, it's close by your ear on the left side, if you're right-handed, and that's more of like, what did I hear? And Broca's is, how do I respond? One other theory, other than evolution and sort of basic biology, is this hands theory, which I find really interesting being a lefty. But the idea is that we ran out of hand gestures. So we started with this onomatopoeia language and pointing, and literally just ran out of ways to point. So we had to develop more words to aid our communication abilities. Quite obviously we have ASL now, and pointing is more sophisticated, but we are talking about a long time ago at this point. But we sort of ran out of ways to sign things, and so words were easier than that. It allowed us to add that complexity to the system. And there is some support for this idea. Our brains and grade 8 brains both have hemispheric specialization. So what that means is that language tends to be on the left side of the brain. Again, unless you're left-handed, then it tends to be on both or the right. But in general, we're going to talk about right-handed people. So language is on the left-handed side. And we both have Brodmann's 44. Brodmann's 44 is Broca's. And in us and great apes, any kind of hand gesturing, like this, like I like to do, activates Broca's area. So you'll see that even though the frontal cortex here, where the motor cortex is only part of Broca's, they do touch, the act of using your hands in any form to either add emphasis or to make shapes with your hands will activate as if you're speaking. So if they have people doing stuff and you ask them not to use hand gestures, one, it's really hard for people, but the other thing that'll happen is if we have you don't speak but use the hand gestures, you still see Brocas. Well, it sort of worked. One cat decided to move. It was over there. There you go. All right. And so back to this left-handed issue. So some species do have left hemisphere dominance for sound production, but don't indicate a handedness preference. So there are other animals that have the sound system is on the left side, just like humans, but they don't show a preference for hand dominance. We show preference for hand dominance. There's it's about 10 to 15% left-handedness is what we think after realizing that left-handed people weren't needing to be forced to be right-handed. And so we do show very strong hand dominance. And the idea is, and I just find this super fascinating, is that evolutionarily we gave up left-handedness equality, so 50-50 use, to be able to speak and gesture. And so we have a right-handed dominance. This makes sense if you think about the cross in your brain. So left side tends to control language and gesturing, and the left side of the brain also controls the right motor cortex, or the right side of your body movement-wise. So there's this cross. Would you be cute somewhere else? There's this cross. What's the word I'm looking for here? Hemispherization? I don't really know. But most people know that left side of your brain controls the right side of your body. So as I am speaking, the sound production goes with the gesturing, right? And so the gesturing is mostly controlled on the right side because I've given up that left-handed ability. Because many animals that show this left-handed dominance for sound production are 50-50 when it comes to gesture production dominance. Some other theories, we have had evolution, biology, handedness, and that kind of goes together, the biology and evolution stuff. They're hard to separate some because evolution is a bit about biology, is this interactionist theory, is that language and evolution interacted together with the environment. So it's not all nature, it's the social pressures. So linguistic skills are really necessary for complex symbol processing. So we talked in the first lecture about how language is an abstract symbol system, and so we need an abstract symbol system to process in our world. So we've talked a little bit about how it's hard to think about thinking without thinking in a language, and so language really allowed us to expand on our complex thinking because now we had a way to do the complex thinking. So it's taking those cognitive skills that we had because of biology and evolution and reconfiguring them in a way that allowed us to move forward. So we took those basic cognitive areas of the brain that were there, like Broca's, and decided to reuse them in a different way. That's the idea anyway. And that's an interaction theory because it's not just nature, it's not just evolution and biology, it also includes the environment. So this next section is about animals. So we're featuring guest star of the Grace and the Cat here. And the question is, do we think that animals have language? Most people think that animals have some sort of language, something, because obviously I wouldn't know that he wanted ear pets if he wasn't communicating to me in some way, right? But the argument that animals have a full language like we do doesn't tend to hold water. But some sort of something, right? So to start this section, we're really going to talk about what is language. It's a communication system. And so communication is the transmission of a signal or a symbol that conveys information. So the sender of that signal benefits from a response. So you don't tend to just talk at people, except what I'm doing, I guess. But if I were in a classroom, the response might be head nods or writing or something. So there's this exchange of information, and that signal conveys the information. So we're using spoken language here predominantly because animals don't write. And so the sound is, so we're transmitting sound that's conveying some sort of information, and that recipient is going to respond that would benefit me in some way. So there's this back and forth is what this part argues here. Okay, you're getting my nerves. Cat trap on the floor. Okay. So some communication system examples that we know animals do. So animals have smell signals, they're pheromones, that they tell ants, that they indicate where something is. Honeybees do this like wiggle dance circular 8 thing to indicate where to find flowers. Primates have use their visual systems. They have auditory sounds that they make. They touch things like we do, and olfactory signals, so smells. So primates are close to us evolutionarily and biology-wise, and they tend to do a lot of the same things we do. So they have visual cues, sound cues, and they touch things. And then dolphins and whales both have very complex systems as well. There's some really fascinating research on dolphin language going on right now. And so if you just Google dolphin language TED Talk, you will find one of the main researchers in that area. And she talks all about these special symbol boards that they've created for dolphins to study their language. Okay. So let's define language and see if animal symbol systems match our symbol systems. So we've done this before, but how will we define language? We're really going to get more complicated now. Okay. So there's a feature list of things that you have to have. It's in your book that you should look at. So it's Hockett's feature list. I think you can also just Google this, and it's really long. And there's this whole list of things that he thought that human language had that maybe animal language didn't have. And so he kind of made this list and mapped onto what do we think the overlaps are. And so we're just going to talk about a couple of them, but you should look up the list. Okay. And animal language tends to meet a lot of those. And so the biggest ones is that language is arbitrary. So there is no relationship between the sound and the symbol. And there's no relationship between symbol and meaning. And so it's an arbitrary symbol system. Semanticity is that things have meaning, but it's unrelated to their symbols. Openness means that we're expecting this sort of like back and forth system. So if a lot of the animal languages meets these rules that we've agreed upon, why do most people still say no? Animals don't have language like we do. And we're not arguing that they don't have language. Its argument is that they don't have language like we do. Okay. And so our language, what we're arguing is special, is that we have voluntary control over the language, and we're creative. Creativity always is the thing that people come back to. Animal language does not seem to have that richness that our system does, and they don't use the language creatively the way that we do. So we have a voluntary control, and that includes all of those grammar rules about repetitiveness or recursion, I think from the last chapter, and we use it creatively. I would argue creativeness is like the number one thing that people get stuck on as the reason why animals don't have language like we do. Okay. So our language has some 5 properties of syntax. So language is a discrete combination system. Meanings are retained when information is combined. It's a bit tricky, but that means that the cat here is still the same if I combined it in a sentence where I was talking about it's Grace and the cat, or I said the cat litter box is blah blah blah. We're still talking about cats. Example, the reason that doesn't totally hold is because of idioms. So if I say it's raining cats and dogs, you don't literally think it's raining cats. Syntax, the combinations are ordered for meaning. So that's the word order idea is very important. sentences are built around verbs, so we're built around action systems, and so we have noun phrases and verb phrases. Verb phrases are the most important piece. There's a distinction between content and function words. Remember that content words are the words that, like nouns, verbs, adverbs, adjectives. Function words are your prepositions, your conjunctions, your determiners. They're the ones that do the work of the sentence but don't tell you what is happening. And then recursion. So I think that I think that I think. Okay. Go away. He literally has been sitting in that box for hours. It is what it is. Okay. So, can we teach animals language? This section has a bunch of YouTube videos that I'm going to recommend you watch on your own because they don't really translate very well in these media site videos. What are you doing? So we're communicating right now, and he's saying, I want pets. You should stop recording. So can we teach animals language? Go watch the YouTube videos. You can click on them in the PowerPoint. And watch them, as much of it as that you're interested in, because they're about fun animals and the things that they do. Okay. So Rico is a famous dog that learned over 200 object names. And what they would do to test Rico is they would put a bunch of objects that he knew and he would bring back to you, and then test him on something new. So we're going to give him a new toy and see if he knows, if he can figure out the new toy. Because kind of process of elimination. Process of elimination. If you ask me to find something and I've never heard that word before, and I have a bunch of stuff I have seen before, I'm going to pick the new thing out. Children do this when they're learning categorization. And so Rico was able to do that. He was able to find the new things in the room. But if you asked him to separate toys into categories like children would be able to do, they weren't able to do that. Okay. I can't find the video for that one anymore, but you can watch a video about Chaser, who is a psychologist dog who does a very similar type of thing. And bonus, Neil deGrasse Tyson is the one narrating it and testing the dog for his categorization skills, and it's a lot of fun. So we can teach animals object names, which is an important component of a symbol system, right? So the symbol and the word for the object and the object themselves is an arbitrary link. Okay. Some other famous animal language is Alex. Alex was an African gray, which is a parrot, that is famous for learning simple language. And that same researcher who worked with Alex is then linked to in the YouTube video here, working with a different parrot. And they were able to teach parrots lots of categories. They would ask them questions. They had intelligent answers, but still no creativity. And so work with African grays is really popular because they have the language skills and intelligence levels of about somewhere between a 2 and a 5-year-old. And then there's a ton of research on apes, bonobos, chimpanzees, great apes, tons of research, because they're cognitively not that different from us. One of the biggest differences is the throat system, but they still have Brocas, and Broca still activates when they're gesturing. And so realistically, they're not that different from us, so maybe it's not a stretch to think that they might have language, but they just don't have quite the right system to output language in the way that we do. And so there's some implications for this. It's that if they don't have a language is not really an essential need, which is the argument for that evolutionary theory that it's an essential need, so natural selection, for many of our basic cognitive tasks. So we don't actually need language to breathe and eat. There are some non-cognitive processes necessary for development. So this is the idea of just basic development is required for linguistic development. And some non-cognitive things like the throat system. And cognitive limitations, like basically they're not as smart as us, does not hold. Right? Maybe it's just that they don't have quite the right system to produce language. So I'm going to walk you through a couple of the famous examples. So there was, for a while, people were raising chimpanzees with their children at the same time to see if they just stuck them in the right environment. So this was a little bit of the testing environment versus genetics theories. And so this research was by Kellogg and Kellogg. It's not the same people as the cereal companies, but they raised, I don't know how to say it, Gua and Vicky, never heard it pronounced aloud. They were raised with children to see if they would pick up language, and they were both unable to learn how to speak, which to me is kind of like, duh, because they don't have the right system, the same larynx and voice box that we do, so of course they're not going to learn how to speak. But they weren't able to learn language like the children were. So this was, in theory, a blow for animal language. But it was also early in the research when maybe we didn't quite understand some of the things we do now quite as well. So instead, some of the more promising research has been with Washoe and Kanzi, and the newest, one of the newer apes is Tico. And so most of this research is really focused on sign language, or what's called a lexigram board. So lexigram board is kind of like, well, they have iPads now. There's a video where you can watch Chico playing on an iPad with his board, but it's basically just like a symbol board that you would pick the symbols out of to be able to speak. So it's almost like if you could write down ASL, which seems a little silly since ASL is a sign language, but it's kind of like a picture language in a sense. So you can watch the video on Washoe, highly recommend, but I watched some of the tests where I'm recording YouTube videos and it doesn't really work. So I'd watch those on your own. But Washoe was taught ASL and raised as a child, toilet trained and everything. And she was able to learn 200 plus signs and did some of the very same things that children do when learning language. So overgeneralization is when we tend to use nouns and verbs in ways that work for other things. So if a flower, flowers do not smell. They smell. We smell the flowers, but flowers do not walk around and smell each other. It's not Alice in Wonderland. But you can overgeneralize that. Smell is a verb, so any noun-verb combination works. Overgeneralization is normally applied to past tense, like I go to the store. Okay. She was also able to create new signs for things she didn't know. So she saw duck, and so she signed the word for water and for bird because it was literally a water bird. So if you've ever seen those really fantastic memes about renaming animals, that's essentially what she did. And there was some basic syntactic structure, just like kids would do. So she would say "washo sorry" to apologize, and some sensitivity to word order. So there was a lot of promising research here because it really showed that they did have the same sort of system that we did, with some basic understanding of word order and sensitivity to that syntactic idea that we do. And she actually did teach it to some of her offspring. So this was one of the most promising areas because it showed a lot of the things that we were missing, except creativity. And so Sarah was chimpanzee, don't quote me on this, that worked with Premack, if you've heard the Premack principle, same guy, and came up with Premackese, because name things after yourself, where this idea that symbols and shapes can be manipulated for language. So she had this symbol system, I think it was ASL, and was able to create some complex sentences and some novel sentences with substitutions. So like, I like ice cream would be a sentence that I had learned, but I could also say I like cheese and substitute the noun, or I eat ice cream would be substituting the verb. So she was able to creatively use a little bit by substituting out words, which is how children first learn some of the things that they say. So if you've ever seen this, I spend too much time on the internet, but those funny things that kids say, and you're just like, where the hell did that come from? What they're generally doing is taking something they've heard or a rule that they know and substituting in other words to see if it's a valid use of those words in the sense of how people react to them. Nim Chomsky, which is a play on Noam Chomsky, is a chimp that was taught basically ASL, and his short sentences showed word order, his longer sentences showed repetition, which is what children tend to do. And there's a whole documentary on Nim Chomsky, and then there's actually a YouTube video on Noam Chomsky's reaction to Nim Chomsky that you can watch. So it showed some of the things that you would expect from kids. And I would say the biggest amount of research has really come out of what used to be the Great Ape Foundation. And these are bonobos. So Kanzi is one of the most famous ones. And they were learning lexigram boards. I don't remember if lexigram boards came from this lab or if it just was something they made the most popular. And so Kanzi was able to show the spontaneous use of symbols. So he was sensitive to word order, and he had the language of around a 2 to 3 year old. He was exposed very early to language, and he was always around people. And so that may be the real crux of it, is that you have to be, they had to be around people, so that environmental component, and exposed very early, which is sort of the critical periods hypothesis. There are tons of videos on Kanzi if you're interested. One of my favorite ones is if you Google Anderson Cooper, and I think it's Kanzi, but if you Google Anderson Cooper and Great Apes, you will find a video of Anderson Cooper in a bunny suit with the great apes talking to him. It's quite funny. So you can watch Kanzi in action on one of these videos. It's not the Anderson Cooper one, but this is a video of him using the lexigram touch board, working with Sue Savage Rumbaugh, who did most of this research. So here's an example of the lexigram board from that particular lab. They are random symbols. Sometimes the symbols match the object, but often they don't. So you couldn't argue that just he knows it's a grape because it looks like a grape, and that doesn't really make it arbitrary anymore. But has some quite complex symbols on here. Liz for Liz Pugh, who also worked in that lab. Here's cake, celery. So the symbols are random and arbitrary to make sure that it maps onto what our language is like. In some of the newer videos, if you watch, it's really quite amusing because they have them printed out, they have them on touch screens, they have them on iPads, and they're even wearing them on their shirts. So there's lots of exposure to these boards, and the people working with the animals use the boards a lot as well. So now to the criticisms part of this section. So it's kind of like, ooh, this is awesome. Animals do have language, except ASL, so American Sign Language, is very symbolic, and it differs from these boards. So that may match the natural gestures apes use. So the reason the ASL things may have worked is because it's sort of mapped onto the way that you would gesture naturally, which does not imply that they're learning language. It implies that we're learning stimulus response. Okay. A lot of these examples that people give that talk about this is creativity and this is syntax are anecdotal and don't really show you the before and after. So it may have been that they have just been saying random words and they came upon a sentence that was syntactically correct and they're just telling you that piece. So it doesn't, the data is sort of reduced. It doesn't show you them just testing the language till they get a positive response from the researcher. And many of the events are situationally cued. So that would be behaviorism. So we really need to show a strong, something separate from environmental influence to really show that this is language. Because even the hardest emergent person, which is the sort of environment, kids learn everything from their environment, still knows that there is Broca's. And so there are still genetic components to this. So kind of the big overall here is that animal language tends to lack a syntactic structure. They don't ask questions about language, whereas children tend to ask questions about their language, like, can I say this, sorts of things, and they're testing the language. They tend to only sign in verbs and nouns, so there's no function words, but to be fair, ASL tends to lack many function words as well. And there's lots of repetition. It's usually to get some food or other object, so it is goal-oriented based, which is also a human thing. But the main issue with really ape language is if the understanding of sounds, the symbols, is the same as our understanding of symbols. And I don't know if there's a good way to solve that problem, really, because you can't really ask them. Okay? We can't be sure of their ability to learn grammar. So we can learn simple framing of grammar, that's simple syntax, which is called complex conditioning in behaviorism, but probably not that same complicated hierarchical grammar that we use. So they don't tend to learn embedded clauses, for example. And so that is where this first one's going to end, and then we're going to go into some of the other ways that language has developed and talk about biology and social cues and cognitive components to language.